Hello, everybody. Hope you guys are doing well. So, today we would be starting with statistics, and then we'll try to understand a bit about um, uh, like uh, how statistics is, uh, and then we will later on move on with O'Reilly. Oh, sorry, we'll move on with machine learning algorithms, and then we'll try to implement some code using NumPy as well. Okay. Uh, okay. So the first step is basically the first topic that we are going to learn is basically. Okay. Let's close this as well. Let's get rid of this. The first thing that we are going to study is exploratory data analysis. As the name suggests, so in this we will be exploring about data. The word explore is basically we are going to explore about how our data is being given to us, and then we'll try to perform a little bit of analysis as well. So as a discipline, statistics has mostly been in the past century. Probability theory, the mathematical so the foundation was probability theory is what and how statistics was founded. Now, it was developed in the 17th century to 19th century by so then two prominent scientists. One of them was Bayes or Thomas Bayes, who got the Bayes theorem. Then you had Pierre Simon Laplace transform. Again, these are uh, these are all scientists who have developed some good theories, right? And then you have Carl Gauss. Now, in contrast to purely theoretical nature of probability, statistics is an applied science considered with analysis and modeling of data. Modern statistics, such as rigorous scientific disciplines, so the root goes back to like 1800s. Um, 1800s, and Francis Galton and Carl Pearson in the early 20th century were the leading. So then you have 1800s. The root is till like going till. Then you have something called as Carl Pearson, some person named okay, some and Francis Galton. These two were in, and then R.A. Fisher in the early 20th century was a leading pioneer of modern statistics. Now they introduced key ideas such as maximum likelihood design. Now these and many other statistical concepts live largely in the research of data science. The main goal of is to explain concepts and clarify the sequence or importance or lack thereof in the context of data science and big data. Now, in this exploratory data science is basically is a EDA is a comparatively new area of statistics. The classical statistics will mostly focus on exclusively on inference, sometimes complex set of procedures for drawing conclusions about large populations and small samples. In 1960, John W. Tukey called for a reformation uh, in his seminal paper and then Future of Data Analytics. He proposed a new scientific discipline called data analysis that includes statistical inference as a source component. The Turkey forced the links to engineering. So this is basically how EDA came into existence. Okay. Now, elements of structured data. So like what does our data contain? The data come from many sources, right? You can data can be any useful information, right? So for example, you can have data from sensor measurements. Okay, you can have data from events, then you can have data from text, images, and videos, and so on and so forth. The IoT is spewing out streams of information. Much of this data is unstructured. Images are a collection of pixels, with each pixel containing RGB color information. Now, text are a sequence of words and non-words characters, often organized by sections, subsections, and so on. The clickstream and sequence of actions by user interaction with an app or a web page. In fact, a major challenge is to harness this torrent of raw data into actionable information to apply sophisticated statistical concepts that will later concern and be processed and manipulated into a structured form. Now it might emerge from a relational database or be collected for a data. Right, it can be collected for study. Okay, so now basically what is saying, there are different sources of data. Either you can get it from, there are multiple sources. Now you may even the images are data, right? Because an image is basically made out up of pixels, right? Same is with video, you have frames, right? So even this is data. Sensor measurements can be like raw values, right? It can be even a decimal value, or you can have a whole number like 40, 50, and so on. Now, now let's see some key terms with respect to how these data types are classified, right? So let's see data types, or basically different types of data that we can have. The first is continuous, right? So the first type of data is basically something called as continuous data. The continuous data is basically data that can take any value in an interval. So it can be any value in an uh, for example, if you think graphically, so this is my graph, right? I mean, it will be more clear when you understand this. Like, what do you exactly mean? So let's see this. No, yeah. Suppose this is our graph, right? And then this is the origin. And let's consider a range from here, right? So let's have one marking here and one marking here. So between these range, there are infinite number of values, right? So continuous values are those which can take any values between a given data range. They can be decimal or anything. So there is no restriction on the type of value. It has to be a whole number. This is basically what we call as continuous data. Oh, let's have the little bit. This is basically in this range. It can take any value. So then interval, basically interval is like a set, right? So I'm saying from year to year, you can take any possible values. And then the next type of data that we have is discrete, right? Discrete, it will take only uh, it will only take constant values. For example, it will only take integer values. Okay, so now what are integers, right? So okay, let's yeah. Second type we have is it will take only mm, integers, uh, integer values. such as counts. This is basically discrete. So basically, these are integers, right? Or whole numbers. So you can have one, then what happened? Two, three, four, and so on. Now it can, so integers are existing on both side of the frame, right? You can have them to the left and the right side of the origin both. So uh, this is one. This is another integer. These are basically continuous, right? Uh, so these are basically integers, and so this can take any value. Uh, yeah, so the difference between whole numbers and integers is whole numbers is not present on the negative side. So you don't have. So these are, so integers include both the negative. So this is the negative number line, and this is both. So an integer will contain both of them, whereas a whole number will only contain the positive part. So this is my whole number. That is only having positive. This is something called as whole number. So you can say, so you can say whole numbers are a subset of integers. That means if I represent a Venn diagram, if these are integers, right? So if I say this is my uh, if I say this is integers, now this will contain both positive and negative, right? A small section of it will be positive, right? So whatever is positive, uh, those are basically my whole numbers. Zero is neither positive not negative, right? So this is, these are positive integers, and these are all subset, like basically out of whole integers, a part of it is positive, right? So those are basically a subset, and this can be called as my whole numbers as well. Okay. The categorical is bit data that can take a specific value set of values representing a set of possible categories. For example, let's the other type of data that we have is basically category, right? For example, one common is basically male and female, right? This is categorical. So you can divide the population into major types, right? For example, that you can have male or you can have female. Like in a broader sense, we are dividing the population into two types, right? This is male and then this is female. The other way is basically to categorize data will be uh, based on their origin, right? For example, People living in Asian subcontinent are called as Asians, and those in uh, the other continents are called as, for example, if someone is living from an Asian, so he's called as an Asian, and if someone is from an American continent, then they are called as Americans. And so American will both includes both, right, north and south. Then you have something called as binary values, right? So binary, it's very, like, you can, from the name itself you can guess, right? So binary values are either going to be 0 or 1, 0 or 1. And then you have ordinal. Now categorical data, that is, so ordinal are basic. So then category values can be divided into two types. So you have category values, and these are further classified as ordinal and nominal. Ordinal is basically in which the order of the data is important. So it's a category based data whose order is important, where order is of utmost importance. So this is my ordinal. And then when the order is not important, that data is called as nominal. So you have nominal, basically where data ordering out it's a type of categorical data where order is not important. Now there are two basic types of structured data, numeric and category. Now numeric data comes into two forms such as continuous, wind speeds, and discrete. Okay, so in a broader sense, data can be classified into two ways, right? One is numeric based, and then other is category based. This is numeric, and this is category. So in numeric, we have two major classification: continuous and integers. Continuous is basically can take any value in an interval. Now these will only take integers value in an interval, and the other thing that we said is whole number is a subset of integers, right? And 0 is neither positive nor negative. Then we come to category. So category we have two, right? So one is ordinal and one is nominal. So ordinal is a category data where the order is important. Nominal is a category data where um, the order is not important. Okay. Now category data can take a fixed set of values. For example, so category will take a fixed set of value. For example, you can categorize TV as LCD, plasma, etc. The binary data is a very special case of categorical data. So okay, binary. Okay, so you have one more major classification of category as binary. So it can take only 0 or 1. Yeah, even we are having two categories, right? 0 and 1. So you can call it as a category data as well. Another useful type of data is ordinal, in which the order categories are ordered. For example, here you have numeric ordering, right? 1, 2, 3, 4, and this order is important. You can, if the order is misplaced, then it will cause an issue. Now, why are we studying so much about data types? Is basically for data analysis and predictive modeling. The type is important to help determine how to display it, how to perform the analysis, and how to do the evaluation of that model. So then the condition that arises, why do we need, or why do we need to understand about data types, right? There are so many. So why do we need? Because depending upon what type of data you are working with, your tools will change. For example, if you are working with a category based data, you will use some other so basically tools and representation is going to change. Secondly, the model evaluation is going to change. How to evaluate, like the tool or the mathematical formulas that we use to evaluate the model will change. And third is how to store. Storing will change, and computational time or performance will also change based on the data or computational time. In fact, data science, okay. Most important, the data types for a variable determines how the software is going to handle. Software engineers and database programmers may wonder why we even need categorical and ordinal data. After all, categories are merely a collection of text or numeric and the underlying database. Okay. So then, why are you saying then? Why do we need specially to identify category? So that we can signal how the software is what like different statistical procedures are going to be followed, how to do a chart, and how to represent it on a graph, how to do fitting it in a model, and how does it behave. Now key ideas. Now okay. um, Now we have something called as rectangular data. The typical frame for reference of an analysis is data science is rectangular data. So basically, our data will be arranged in a rectangular format in a rows and columns, right? Basically, so now we are talking about rectangular data. So yeah, something called as rectangular. Okay, now our date. Okay, so then yeah, this is something important. Now, what is a data frame? So rectangular data means we will be dividing our data into rows and columns. So this is row one, row okay. Then yeah, one more. Oh no, just click here. Yeah, one more row, and then we have multiple rows, right? So let's make it 200. 95, 90. Okay. Let's yeah. This is basically rows and columns. Okay. And let us have column over here. So these are columns. Now the rectangular data is the basic structure for a statistical and machine learning models. Now the data like a spreadsheet. So this entire is nothing but my data frame. This entire thing is nothing but called as a data frame. Now these individual columns is nothing but my feature. So you have this column called as feature 1, feature 2, feature 3, feature 4, and feature 1. Many data sub projects involves predicting an outcome and often a yes or no. The features are sometimes used to predict the outcome. Okay, we'll see this later on. Now records are row in a table. So basically, and individual rows are called as records. These are my records. So to sum it up, the entire data is based or a spreadsheet is nothing but my data frame. Now these are my features columns, and the individual rows are nothing but called as records. A rectangular data is basically a 2D matrix with rows indicating records and columns indicating features. The data does not always start in this form. So it might, so we will not always get the data in the rectangular form. We might have to do some processing to get it to your the data. Okay, so that it can be represented as set of features in data. So data in a relation table must be extracted into a single table. So in relational tables, what will happen is, so when we are extracting data from a relational database, so you might have different tables, right? And these tables might be linked to each other using some sort of key, right? So to perform analysis, we need to join both of them and create a single 2D array. Okay. Must be extracted and put into a single data analysis and modeling task. Now in table 1.1, for example, okay, he has given one example. So how a typical you can, so let's see, data format. Yeah, this is one typical example of your spreadsheet, right? Of data arranged in rows and columns. So this is basically you have rows and different columns. Now data frames and now traditional databases are more one or more columns designated as an index. Now this can vary depending upon the efficiency of certain SQL queries in Python. With Pandas library, the basic rectangular data structure is a data frame object. By default, an atomic integer index is created data frame based on order of rows. Okay. Now, data frames and indexes, we'll see this later on. The non-rectangular database data structures, for example, those data. So this is nothing but where we have data in the form of rectangular. Now, for example, social media relationship, right? Those are non-form, non, what you say, non-rectangular data structures. You can have them as well. Okay. Okay. The next thing that we need to know is certain mathematical terms, right? Okay. No. So yeah, I guess um yeah. So this is all for today's lecture. I'll see you in the next one, and then we'll start with something called as estimation or estimates of location, and we'll see how to find the find and like we'll see different types of concept. First, we'll try to understand what do you mean by estimates of location, and then we'll try to s- uh, see a little bit of mathematics, and then we'll go on from there. So yeah, that's all for this lecture. See you guys in the next one. Till that time, take care. Bye.